In this video, we will discuss binary classification using neural network. So far, we have seen how the neural network can be used in supervised learning. As you remember, when we started our classes, we have discussed the two main concepts, linear regression and logistic regression in the supervised learning. The linear regression allows you to predict a value based on available data, the pattern of the data, and the features. And the classification, where you can classify the data. This example is of binary classification. In the next video, we will see multi-class classification. When we say binary classification, there are only two options, either 0 or 1, that is positive or negative. Let's take a basic example where we have one email and then we feed the features of that email, some of the basic extracted features of the email to a machine learning classifier. This classifier will learn by itself, and based on the labels given in the training dataset, it will learn the features and the rules how they can be applied to identify a mail as a spam or a not spam. Later, when the classifier or the model will be tested with the test dataset, the classifier will be able to predict or will be able to classify whether the inputted email or whether the email which is received in the mailbox is spam or not. When we say spam or not spam, that is the binary classification, because you have only two classes available with you, and it's very easy to identify them in the terms of zeros and ones. 0 refers to spam and 1 refers to not spam, or it can be vice versa. 1 refers to spam, 0 refers to not spam. But the purpose is you identify them based on their characteristics, and then you label them either 0 or 1 or positive or negative or spam or not spam. The second example which we will be practically seeing in this uh, video is about the tumor. This is very helpful application of machine learning in the medical science or healthcare. Based on the tumor characteristics, like the size of the tumor, weight of the tumor, depth of the tumor, or hardness and softness, you can classify it as a malignant or a benign tumor. Malignant is a serious kind of tumor, a severe and a difficult to handle tumor, while benign is comparatively easy to handle and is less uh, risky. So again, like spam and not spam, here you are extracting the features of tumor and then you forward those features to the ML classifier. The classifier, based on the training data set where you have already labeled different types of tumors with malignant and benign labels, it learns and it adopts the way of classifying the tumors. This is basically done in the training phase, and then later with the test data set, the classifier itself can classify the input given for the tumor and then can label it as malignant or benign. This is a very common application in the healthcare, and we will be using Scikit for this example, and we'll see how this classification can be applied to label a tumor as a malignant or benign. Before we move to the actual practical example or the code, let us just get acquainted with a term called perceptron. Earlier we have said that the artificial neural network is based on the biological neural network. We had biological neurons and then we created the artificial neurons. These artificial neurons are also known as perceptrons. Perceptrons are the basic components of an artificial neural network, where each neuron refers to a single perceptron. The perceptrons can be in the single layer or can be in the multi-layer. We will see this practically now, as this diagram represents an artificial neural network having only one output layer, that is layer 3 h theta x. And since we are working on a binary classification, our requirement is to classify the tumor as malignant or benign. We are expecting some result which can tell us whether it's a malignant or it's a benign tumor, and as we said earlier, this can be represented in the form of 1 or 0. So the last element h theta x, which is an output element, can represent either 1 or 0. 1 can represent malignant and 0 can represent benign tumor. and this can tell us exactly whether the tumor is malignant or benign. So we will use Jupyter, the Anaconda option for binary classification, and the binary classification will be achieved using Scikit. There are multiple ways of doing this. We will be using Scikit first of all, and then we will see other options like TensorFlow and Keras. So let's begin with the first section. As you know that each cell here is a separate cell and can be executed separately in Jupyter. So we must have seen it earlier. The first section is the import section where you are importing the sklearn. This is the scikit-learn library, and we want to work on the breast cancer dataset, which is already available in the scikit-learn datasets. We are importing the breast cancer datasets, and then there are other options like train test split to split the data into trained and test datasets. And next is the MLP classifier. You can call it multi-layer perceptron classifier, and finally we use the matrix for some matrix related operations. The first thing is to load the database, and we are storing the data into the data. We are loading the data of breast cancer which is available in the Scikit itself, and we are storing it into the data variable. So as you know that when you are loading a data set into the data variable or any other variable, it has two components, data and the target. The target represents the labels mostly, and the data is the actual data, or it's also known as the features of the data set. So we want to see what the Y names are, basically the names assigned to the target data set, and also we want to see the X names. These names are nothing but the names of the features available in that. So if you simply want to see their names and just arranging the data in the proper fashion. So now you have Y names and you have X data, Y data. So let's first print the uh, Y names. These are the actual labels. Starting from the cell 1, I am just compiling and running it. Then moving to the next cell, loading the data set, and then the next is where you are putting the feature names into X names and target names into the Y names, data into X and target into Y, and then we are printing the Y names. So as you can see, the Y names are the two labels assigned to each dataset record, that is either the malignant or benign. And what are the X values? What are the features? So we'll see the column names there, which are the X names. So if you run this, you can see that there are various features of a tumor. Around 30 features have been taken: mean radius, mean texture, mean perimeter, etc. And each of them refer to the value, float value, or some integer value, and then they are telling the dataset whether the tumor is benign or it's a malignant. Next step, let me remove this comment. The next step in our code is the splitting the data into xtrain ytrain and xtest ytest. This can be done simply using the train test split function of the scikit. You are providing the x, which is your features set, y the labels, and then you are restricting your test size data to 0.2. This is 20% of your actual data, and remaining 80% data will be kept for the training purpose. By default, you are keeping your random state to 0. The next step, let's run this, and next step is the defining or instantiating the MLP classifier. It's available in Scikit and it has multiple features. So MLP is the variable which we are taking, and it's an object of MLP classifier. The MLP classifier, it has multiple parameters to be set. So first is hidden layer size, how many hidden layers you want. So we are saying that we need 200, and then we'll see how it can be reduced or increased to see the performance. What exactly you want to keep in your activation function? We are saying that we want logistic function because we want to perform the logistic regression. So we are saying activation is equal to logistic. Alpha is your learning rate. We are starting with 0.001. Then there is a solver. The solver is equal to SGD, where SGD refers to stochastic gradient descent. Random state is by default kept 1, and verbose is true, and now I am fitting the data with xtrain and ytrain. So I have created a model. I am feeding the data to fit the data into the model to make sure that the model get appropriate results. So let's understand what results we have received here. So starts with the iteration 1 and it goes to the iteration number 137. You just, if you can observe the values, this is the loss. Loss was 0.65, then it reduced to 0.61, 0.60, and when it reached to the loss of 0.239241, it has stopped. And the reason behind stopping this is training loss did not improve more than tol. Tol is the tolerance of 0.00100 for 10 consecutive epochs. That's why it is stopping. Epochs are the number of iterations. So it says that whatever was there in the last epoch, and it did not change drastically. It remained less, the loss remained less than 0.001 for 10 consecutive epochs. So it says that there is nothing significant left now. The loss which had to be reduced has already been reduced, and it cannot affect the model anymore in learning it in better way. These are all variables of MLP classifier. You can study them, and so now your model is ready. It has been fit, and next is to predict. Now we will be providing the 20% of the text data, and we'll see how it does. So prediction part is done, and now we want to calculate the accuracy. So matrix.accuracy score tells you the accuracy because you had 20% of data. You had Y test, which were the labels of 20% of records of the database, which were the actual labels, and then you had predictions. These predictions had been derived by the model. So let us see how much difference they have or how much accuracy you get. So as you can see, it shows the accuracy of 0.9122%. It's almost around 91% accuracy. This is quite significant. This is quite okay for the first example. So we can confidently say that our model has learned it in very well way, that how the data can be identified or how the new records can be labeled based on its experience, and it can be accurate up to 91% in labeling the tumors as malignant or benign. I hope this has been useful in understanding the classification example, the binary classification especially, with help of Scikit. As I said earlier, this can be done with the other platforms, like it can be done with the TensorFlow, Keras, and other things, but we will see them one by one, step by step. In next class, we will see the multi-class classification.